Now, in this lecture, we'll find out the length of line segment X. In the drawing, we have a quarter circle. A or B is a quarter circle. Inside this quarter circle, we have this semicircle. OB is a semicircle. And we also know that side AO equals to 10 units in its length. Our mission is to find out the length of side AM. That's equal to X, according to what is given us in the question. So, first of all, AOB is a quarter circle, therefore this angle equals to 90 degrees. This is a right angle. And also, AO and OB are equal to each other. They are both the radii of this quarter circle, therefore they are equal to each other. But we know that AO equals to 10, therefore OB must be also equal to 10 units. They are both the radii of the quarter circle. OB is not only the radius of this quarter circle, but it is also the diameter of this semicircle. So the diameter OB of this semicircle equals to 10 units. Therefore, the radius of this quarter circle will be equal to 10 over 2, that is 5. The radius of this quarter circle equals to 5 units in its length. We define the center of this semicircle as P. The radius OP of this semicircle equals to 5 units in its length. And the radius PB also of this semicircle equals to 5 units in its length. In the next step, we define the point of tendency of tangent AM with this semicircle as Q, and we'll join points P and Q together by a straight line. Point P is the center of this circle. Point Q is a point, again, point P is the center of this semicircle. Point Q is a point on the semicircle itself, therefore PQ is the radius of this semicircle, therefore it is equals to 5 units. We have here rule number 1. According to rule number 1, a tangent to the circle is perpendicular to the radius drawn to its point of tendency. Here we have tangent AB. This is tangent AB, that is tangent to this circle at point M. Point M is the point of tendency. And we have the radius OM that is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. So here we have, in our drawing, the radius PQ is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then according to number 1, tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, it means that this angle equals to 90 degrees. And this angle equals to 90 degrees according to rule number 1. We have also here rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. In the drawing, we have the common external point, point P. From the common external point, point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule number 2, the lengths of those two tangents are equal to each other. That is to say, PA equals to PB. We can actually implement this rule number 2 in our drawing. Why? Because in our drawing, if we focus on the common external point, point A, from the common external point, point A, we have two tangents to this semicircle, tangent AO and tangent AQ. And according to rule number 2, they are equal to each other. That is to say, AO equals to AQ. But AO equals to 10, therefore AQ must be also equal to 10 because they are equal to each other. Only to rule number 2. In the next step, we will extend side AM and side OB by straight line until they touch each other. And we will define the touching point of the extended side AM and side OB as point N. By doing this construction, we created here the right big triangle AON. We define this angle ONA as theta, and we'll continue to focus on the right big triangle AON. The right big triangle AON. This angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, this equals to 180 degrees. That is the sum of the angles in any triangle. Likewise, in the right green small triangle QPN, according to the same logic, this angle equals to theta, this angle equals to 90 degrees, therefore this missing angle must be equal to 90 degrees minus theta. Okay. In the next step, we'll prove that the right big triangle AON is similar to the right small green triangle PQN. So I write it down. The right big triangle AON similar to the right small green triangle PQN. So why those two triangles are similar to each other? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So this is angle AON in the big right triangle AON. And it is equal to this angle, this is actually angle PQN in the green triangle. Repeat again. Angle AON in the big right triangle AON equals to angle PQN in the green right triangle PQN. They are both equal to 90 degrees. Therefore, they are equal to each other. In addition, this is angle theta. Angle theta is a common angle that belongs to both triangles. Therefore, we can write down that angle theta equals to itself. It's a common angle that belongs to both triangles. So if you relate to angle theta, it belongs to the right big triangle AON. It will be called angle ANO. And it is equal to itself. If we relate to angle theta as it belongs to the green triangle, it will be called angle PNQ. Repeat again. This equation means that angle theta equals to itself. We just called angle theta two different names. Angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle AON, the big right triangle AON. And it is equal to this angle in the green triangle, that's actually angle QPN. Repeat again. Angle AON in the big right triangle AON equals to angle QPN in the small green right triangle QPN. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So I actually proved that all the three angles in the big right triangle AON are correspondingly equal to all the three angles in the small green right triangle PQN. Therefore, we proved actually that triangle AON is similar to triangle PQN according to angle similarity rule. So I write it down. We actually proved that the big right triangle AON is similar to the small green right triangle PQN according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side AO in the big right triangle AON over side QP in the small green right triangle QPN equals to side AN in the big right triangle AON over side Pn in the small green right triangle PQN. It again, we derive that AO over QP equals to AN over PN, and it is equals to side ON in the big right triangle AON over side QN in the small green right triangle QPN. Again, and it is equals to QON over QN. So in total, AO over QP equals to AN over PN equals to ON over QN. So AO is 10 over QP. QP is 5. So AO over QP is 10 over 5. And it is equals to AN. What is the length of AN? AN in total equals to AQ plus QN. AQ is 10, so in total AN equals to 10 plus QN. AN equals to 10 plus QN. Over PN. From the drawing, it is very easy to see that Pn equals to Pb plus Bn, that is to say Pn equals to Pb, that is 5 plus Bn. So in total Pn equals to 5 plus Bn. Pn equals to 5 plus Bn. And it is equals to On. What is the length of ON? From the drawing it is very easy to see that ON in total equals to OP plus BP plus BN. That is to say ON equals to OP, that is 5, plus PB, that is 5, plus BN. So in total ON equals to 5 plus 5 is 10 plus BN. So ON equals to 10 plus BN. ON equals to 10 plus Bn over Qn. Qn is the missing side, so we leave it as it is. In conclusion, found out the 10 over 5 equals to 10 plus Qn over 5 plus Bn, and it is equals to 10 plus Bn over Qn. So 10 over 5 is 2, so 2 equals to 10 plus Qn over 5 plus Bn, and it is equals to 10 plus Bn over Qn. So here a long equation. Those two sides are equal to each other. So we create equation number 1 from those two sides that are equal to each other. According to equation number 1, we get that 2 equals to 10 plus Qn over 5 plus Bn. Those two sides are also equal to each other. So we get the equation number 2 from those two sides that are equal to each other. So according to equation number 2, 2 equals to 10 plus Bn over Qn. Okay. Here we'll multiply equation number 1 by 5 plus Bn. And we'll get that according to equation number 1, two times 5 plus Bn equals to 10 plus Qn Here we'll open the brackets on this side of equation number 1 and we get that according to equation number 1, 2 times 5 is 10 plus 2 times Bn is 2Bn. That is equals to 10 plus Qn. So here we have 10 on both sides of the equation, so 10 will get cancelled and we left only with Qn that is equals to 2 times Bn. Qn is twice as long as Bn. Okay, according to equation number 1. According to equation number 2, two equals to 10 plus Bn over Qn. Here we multiply this equation number 2 by Qn, and we get that according to equation number 2, two times Qn equals to 10 plus Bn again according to equation number 2, 2 times Qn equals to 10 plus Bn. We have already found out that Qn according to equation number 1 equals to 2 times Bn. Therefore we can substitute Qn in this equation number 2 by 2 times Bn from equation number 1. We'll do it now and we get that according to equation number 2, 2 times Qn, and Qn is 2 times Bn, equals to 10 plus Bn. So according to equation number 2, 2 times 2Bn is 4Bn, that is equals to 10 plus Bn. Here we subtract from this equation number 2 Bn, and we get that according to this equation number 2, 4Bn minus Bn is 3Bn, that equals to 10. 3Bn equals to 10. Here we divide this equation number 2 by 3, and finally we get that according to equation number 2, Bn, the length of line segment Bn equals to 10 over 3 units. Bn equals to 10 over 3. You can write down in the original drawing that the length of this line segment Bn is 10 over 3 units. According to equation number 1, we found out that Qn equals to 2 times Bn. Okay, now we can put the value of Bn that is equal to 10 over 3 inside here, inside Bn. In this equation number 1, and we get that Qn equals to 2 times, and Bn is 10 over 3. 10 over 3. So Qn in total equals to 2 times 10 over 3. 2 times 10 is 20, so it is 20 over 3 in total. In conclusion, we found out that Qn equals to 20 over 3 units in its length. Qn equals to 20 over 3 units, so we write down in the original drawing that Qn equals to 20 over 3 units in its length. QN equals to 20 over 3 units. In the next step, we'll complete this quarter circle to a circle. So completed the quarter circle to a circle, and you will extend side BO of this quarter circle until it touches the circle. And we'll define the touching point of the extended side BO with this circle as C. Point O is the center of this circle, point C is the point of the circle itself, therefore OC is the radius of this circle. The radius of the circle and the radius of the quarter circle are the same because we just extended the quarter circle to a circle. And we know that the radius of this circle AO is 10, therefore the radius of the circle CO must be also equal to 10 units in its length. So CO equals to 10. In the next step, I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule number 14. Rule number 14 is true in any circle. So here, in any circle, if we draw two chords A, B, and C, D in the circle, from the common external point P, then PA times PB equals to PC times PD. So in the moment we have a circle, and we have here the common external point, point P. From the common external point, point P, we draw two chords in the circle. Here, this is called AB, and from the same common external point P, we draw also this chord that is called CD. Okay. So in this drawing, the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. So, according to rule number 14, whenever you draw from common external point, point P, two chords to a circle, then PA times PB equals to PC times PD. Okay? We can actually implement rule number 14 in our drawing. Why? Because in our drawing, if we focus on the common external point, point N, from the common external point, point N, we have here two chords in the circle. We have chord MA, is drawn from point N. Chord MA is drawn from point N. This is chord AM. And we have from the same common external point, point N, chord BC. So from the common external point, point N, we have two chords inside this circle, chord AM and chord BC. Okay, so all the requirements of rule number 14 are met, therefore we can implement here rule number 14. Here, according to rule number 14, Nm times Na equals to Nb times Nc. Again, Nm times Na equals to Nb times Nc. So I write it down. We have the common start point N. From the common start point N, we have two codes inside this circle, code AM and code CB. Therefore, according to rule number 14, we get that NB times NC equals to Nm times Na. Repeat again. If we focus on the common start point N, from the common start point N, we have two codes inside the circle, code MA and code BC. Therefore, all the requirements of rule number 14 are made, and therefore can implement the rule number 14. According to rule number 14, Nm times Na equals to Nb times Nc. Again, Nm times Na equals to Nb times Nc. Okay. Here we have to find out the length of this line segment Mn. It is very easy to see from the drawing that Mn equals to Qn minus Qm. Again, Mn equals to Qn minus Qn. Qn minus Qm. Repeat again. For the drawing, it is very easy to see that Mn equals to Qn minus Qm. So Mn equals to Qn. Qn is 20 over 3 minus Qm. So actually found out that in total Mn equals to 20 over 3 minus Qm. So I write it down. Mn, this line segment Mn is equals to 20 over 3 minus Qm in its length. Now we return to rule number 14. According to rule number 14, Nb times Nc equals to Nm times Na. What is the length of Nb? We just found out that Nb equals to 10 over 3 units. Nb equals to 10 over 3 units in its length times Nc. What is the length of Nc? From the drawing, it is very easy to see that Nc in total equals to CO plus OP plus BB plus BN. So Cn in total equals to CO, that is 10, plus OP, that is 5, plus PB, that is 5, plus BN, that is 10 over 3. So Cn in total equals to 10 plus 5 plus 5, that is 20, plus 10 over 3. So in total, Cn equals to 20 plus 10 over 3. Repeat again, Nc in total equals to 20 plus 10 over 3 and it is equals to Nm. Nm, we found out that Nm equals to 20 over 3 minus Qm times Na. What is the length of Na? What is the length of this line segment Na or An? An equals to AQ plus Qn. That is to say, An equals to AQ, that is 10, plus Qn, that is 20 over 3. So in total, An equals to 10 plus 20 over 3. So 10 over 3 times 20 plus 10 over 3. Here we will multiply 20 by 3 and then we divide it by 3 in order to have a common factor with 10 over 3. And we get that 20 times 3 is 60 and 60 plus 10 is 70. So in total in the numerator we have 70 divided by 3. And it is equals to 20 over 3 minus Qm. Here we multiply minus Qm by 3 and then we divide it by 3 in order to have a common factor with 20 over 3. And we get that we have in the numerator 20 minus Qm times 3 is minus 3 Qm. So in total in the numerator we have 20 minus 3 Qm divided by 3. Multiplied by 10 plus 20 over 3. Here we'll multiply 10 by 3 and then we'll divide it by 3 in order to have a common factor with 20 over 3. 10 times 3 is 30 and 30 plus 20 is 50. So in total in the numerator we have 50 divided by 3. So this equation we have on both sides of this equation 3 times 3, that is 9 in the denominator. Therefore, in order to cancel the denominator of this equation, we multiply this equation by 9. And we get that according to this equation, so here we have, after we multiply this side by 9, we left only with 10 times 70. That's equal to, here we multiply this side also by 9. After we multiply this side by 9, we left only with 20 minus 3 Qm times 50. So I already found out that 10 times 70 equals to 20 minus 3 Qm times 50. Here we will divide this equation by 10 and we get that 10 over 10 is 1, so we left only in this half of the equation with 70, and it is equals to 20 minus 3 Qm times 50, and 50 over 10 is 5. Here we'll open the brackets on this side of the equation and we get that 70 equals to 20 times 5 is 100. Minus 3 Qm times 5 is minus 15 Qm. In conclusion, found out that 70 equals to 100 minus 15 Qm. Here we subtract 70 from this equation. And we get that 70 minus 70 is 0. That equals to 100 minus 70 is 30. minus 15 qm. Here we get to this equation 15 qm, and we get that 15 qm equals to 30. Here we divide this equation by 15, and we get that qm equals to 30 over 15, that is 2. So qm equals to 2 units in its length. So here, this line segment qm equals to 2 units in its length. Our mission is to find out the length of line segment AM. That is equal to x, according to what is given in the question. I'll repeat again. Our mission is to find out the length of line segment AM, that is equal to x. From the drawing, it is very easy to see that AM in total equals to AQ plus QM. Again, AM equals to AQ plus QM. Repeat again. AM equals to AQ plus QM. AQ equals to 10. And we just right now found out that QM equals to 2 units in its length. So in total, AM equals to 10 plus 2, that is 12. Also we found out that x is equal to AM is equal to 12 units in its length. And that is the answer to our question. Repeat again. The length of this line segment AM is equal to x is equal to 12 units. So x equals to 12 units in its length, and that is the answer to our question. In the next step, I'll summarize the lecture. In this lecture, we found out the length of this line segment AM that is equal to x, according to what is given as the question. So in the drawing, we have a quarter circle. AOB is a quarter circle. Inside this quarter circle, we have this semicircle. OB is a semicircle. Again, our mission is to find out the length of this line segment AM that is equal to x. So first of all, we know that AOB is a quarter circle, therefore this angle AOB equals to 90 degrees, and side AO must be equal to side OB. Why? Because both those two sides are the radii of this quarter circle, therefore they are equal to each other. But AO, according to what is given in the question, equals to 10 units, therefore OB, this is also the radii of this quarter circle, must be also equal to 10 units in its length. Here OB equals to 10 units. And we know that OB is not only the radius of this quarter circle, OB is not only the radius of this quarter circle, AOB, but it is also the diameter of this semicircle. So we know that the diameter of this semicircle OB is 10. Therefore, the radius of this semicircle must be equal to 10 over 2, that is 5. The radius of this semicircle equals to 5 units in its length. We define the center of this semicircle as P. So OP, that is the radius of this semicircle, equals to 5 units in its length. And PB, this is also the radius of this semicircle, equals to 5 units in its length. We define the point of tendency of tangent AM with this semicircle as Q. Then we join points P and Q together by straight line. Point P is the center of the circle, point Q is the point on the semicircle itself, therefore PQ is the radius of this semicircle, that is equal to 5 units. We have here the radius PQ is drawn to the point of tendency, that is to say it is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. Then we focus on the common external point A. From the common external point A, we have two tangents to this circle, tangent AO and tangent AQ. According to rule number 2, it says that the lengths of two tangents from a common external point to a circle are equal. Tangent AO must be equal to tangent AQ. But AO is 10, therefore AQ must be also equal to 10 units in its length. Then you extended side AQ, extended side AM, and side OB by a straight line until they touch each other. We define the touching point of the two extended side AM and OB as N. By doing this construction, we created the right triangle AON. In the right triangle AON, we defined angle ANO. This angle is theta. So we continue to focus on the right triangle AON. The right triangle AON, this angle equals to theta according to our definition. This angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, according to the same logic, if we focus on the great triangle QPN, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Then we proved that the right big triangle AON is similar to the small green right triangle QPN. Why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, this is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself. It's a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles in the right triangle AON are correspondingly equal to all the three angles in the right green small triangle PQN. Therefore, we actually proved that those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that AO over QP equals to NA over PN equals to ON over QN. AO is 10, QP is 5. What is the length of AN? From the norm, it is very easy to see that AN in total equals to 10 plus QN. AN equals to 10 plus QN over PN. What is the length of PN? PN in total equals to 5 plus BN. Again, PN equals to 5 plus BN. And it is also equals to ON. What is the length of ON? ON in total equals to 5 plus 5 plus BN. So in total, ON equals to 10 plus BN. And ON equals to 10 plus Bn, and Qn is the missing side, so we leave it as it is. So in conclusion, we found out that 10 over 5 equals to 10 plus Qn over 5 plus Bn, that is equal to 10 plus Bn over Qn. 10 over 5 is 2, so 2 equals to 10 plus Qn over 5 plus Bn, that is equal to 10 plus Bn over Qn. Those two sides are equal to each other, therefore created equation number 1 from those two sides that are equal to each other. So according to equation number 1, 2 equals to 10 plus Qn over 5 plus Bn. Those two sides are also equal to each other. In this way, we created equation number 2 from those two sides that are equal to each other. So according to equation number 2, 2 equals to 10 plus Bn over Qn. So we have here two equations. We multiply this equation number 1 by 5 plus Bn and found out actually that 2 times 5 plus Bn equals to 10 plus Qn. We open the brackets on this side of this equation number 1 and found out that 2 times 5 is 10 plus 2 times Bn is 2Bn. That is equal to 10 plus Qn. Here we have 10 on both sides of the equation, so 10 we get cancelled. We left only with Qn that is equal to 2 times Bn. That is to say, Qn is twice as long as Bn. According to equation number 2, we have already found out that 2 equals to 10 plus bn over qn. We multiply this equation number 2 by qn and found out that 2 times qn equals to 10 plus bn. Now we can substitute qn in this equation number 2 by 2 times bn from this equation number 1. We did it and we found out actually that according to equation number 2, 2 times qn, and qn is 2 times bn, that is equals to 10 plus bn. Equation number 2, we have 2 times 2bn is 4bn, so 4bn equals to 10 plus bn. We subtracted bn from this equation number 2 and found out that 4bn minus bn is 3bn. So 3bn equals to 10. We divided this equation number 2 by 3 and finally found out that bn equals to 10 over 3 units in its length. Here this time 7bn equals to 10 over 3 units in its length. According to equation number 1, qn equals to 2bn. We just right now found out that bn equals to 10 over 3. So qn equals to 2 times bn and bn is 10 over 3, so it is 2 times 10 over 3, that is 20 over 3. So qn equals to 20 over 3 units in its length. This line segment qn equals to 20 over 3 units in its length. Then we completed this quarter circle to a circle and we extended side BO until it touches the circle. We define the touching point of the extended side BO with this circle as C. So point O is the center of the circle, point C is the point on the circle itself. Therefore OC is the radius of the circle. The radius of the circle is exactly the same of the radius of the quarter circle because we completed the quarter circle to a circle. And we know that the radius of the quarter circle AO is 10, therefore the radius of the circle CO is also 10 units. Then I presented to you rule number 14 and implemented rule number 14 in our drawing. According to rule number 14, rule number 14 is true in any circle. So in any circle, if you draw two chords A, B and C, D in the circle from the common standpoint point B, then the following equation will be true, that PA times PB equals to PC times PD. We can actually implement rule number 14 in our drawing. Why? Because in our drawing we have the common standpoint point N. From the common standpoint point N, we have two chords inside this circle, chord MA or chord AM, and the second chord is chord BC. Therefore, all the requirements of rule number 14 are met. Therefore, we can implement here rule number 14. According to rule number 14, NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. Repeat again. According to rule number 14, NB times NC equals to NM times NA. Then we found out the length of NM. From the drawing, it is very easy to see that NM equals to Qn minus Qm. Again, Qn minus Qm equals to NM. So again, NM equals to Qn minus Qm. Qn is 20 over 3, so it is 20 over 3 minus Qm. So NM or Mn in total equals to 20 over 3 minus Qm. Then we return to rule number 14. According to rule number 14, NB times NC equals to Mn times An. NB is 10 over 3 times NC. What is the length of NC? NC in total equals to 10 plus 5 plus 5, that is 20, plus 10 over 3. So in total NC equals to 20 over 3. And Cn in total equals to 20 plus 10 over 3. Okay? NC in total equals to 20 plus P over 3. Again, NC in total equals to 20 plus 10 over 3. And it is equal to Mn. Mn is 20 over 3 minus Qm times An times Na. Na, what is the length of N or Na? An equals to Aq plus Qn. That is to say, An equals to Aq, that is 10, plus Qn, that is 20 over 3. So An in total equals to 10 plus 20 over 3. And again, An in total equals to 10 plus 20 over 3. So here we have 10 over 3 times 20 plus 10 over 3. We multiply 20 by 3 and then we divide it by 3 in order to have a common factor with 10 over 3. So 20 times 3 is 60 and 60 plus 10 is 70. So in total in the numerator we have 70 divided by 3 and it is equals to 20 over 3 minus qm. Here we multiply minus qm by 3 and then we divide it by 3 in order to have a common factor with 20 over 3. So in the numerator we have in total 20 minus qm times 3 is minus 3 qm. So in total in the numerator we have 20 minus 3 qm divided by 3 times 10 plus 20 over 3. Here we multiply 10 by 3 and then we divide it by 3 in order to have a common factor with 20 over 3. 10 times 3 is 20 and 10 times 3 is 30 and 30 plus 20 is 50. So in total in the numerator we have 50 divided by 3. So on both sides of the equation we have in the denominator 3 times 3 that is 9. Therefore we multiply this equation by 9 in order to cancel the denominator that is 9. So after we multiply the equation by 9, we left only with 10 times 70 is equals to 20 minus 3 qm times 50. Here we divided this equation by 10. 10 over 10 is 1, so here we left only with 70. That's equals to 20 minus 3 qm times 50, and 50 over 10 is 5. So in total we found out that 70 equals to 20 minus 3 qm times 5. We open the brackets on this side of the equation and found out actually that 70 equals to 20 times 5 is 100, and minus 3 qm times 15 is minus 15 qm. So in total we found out that 70 equals to 100 minus 15 qm. We subtracted 70 from this equation and found out that 70 minus 70 is 0 and 100 minus 70 is 30 minus 15 qm. So in total we found out that 0 equals to 30 minus 15 qm. Here we added to this equation 15 qm, and finally we found out that 15 qm equals to 30. We divided this equation by 15 and found out that qm equals to 30 over 15, that is 2. 30 over 15 is 2, so qm equals to 2 units in its length. If this line segment qm equals to 2 units in its length. Our mission is to find out the length of line segment AM that is equal to x. Again, we have to find out the length of line segment AM that is equal to x according to what is given as the question, and from the drawings it is very easy to see that AM in total equals to AQ plus QM. Again, AM equals to AQ plus QM. AM equals to AQ plus QM. AQ is 10 and QM is 2. So in total AM equals to 10 plus 2, that is 12. So the answer to our question is that x is equal to AM equals to 12 units in its length. Here, 9 segment AM that is equal to x, it is equals to 12 units in its length. Okay, thank you very much.